Okay, and we're back. So, welcome to week 4. Today we're going to talk about how to use Unity in the second dimension. It's pretty straightforward actually, if you can kind of think about a 3D game and having only two of those dimensions. That's actually exactly how it works. So, 2D Unity is essentially 3D, but with a locked orthographic camera. And an orthographic camera, we haven't talked about projections, matrices, but an orthographic camera effectively takes whatever's out here and maps it one to one onto a plane. So the distance doesn't matter anymore. It's sort of imagine if you were to take a plane of glass and have an object, and you could somehow take a string and connect the glass such that each string was parallel to an object in like each one of the points, and just project that onto the piece of glass. And that's how an orthographic projection works. Unlike a perspective projection, which sort of takes my perspective, my point of perspective against that plane of glass and casts rays out, right? It's more like, imagine if my perspective was infinitely far away from that glass. This gets you get into this stuff a lot more in later stage classes. You don't need to know too much about it apart from how to open up a Unity project that is in 2D. And so let's kind of do that, since this is an online class and you might not get the in-class labs. So to do so, you open up Unity, and I'm gonna go through the tutorial here that you would otherwise be doing in class. So I'm gonna open up a new project. You'll notice that instead of choosing the 3D project, we're gonna choose 2D. And if you hit the little info, it uses 2D apps. Got it. So we're gonna be calling it a clock face, I believe. I think that's the project that we'll be doing. Let me make sure here. Woo! Cool. Yeah, we're going to be making a fun little clock. Great. So we're going to call this the clock tutorial. We're going to create it. Awesome. So cool. Now we have to wait a million years for Unity to open. While we do that, let me talk a little bit about how things work. So the way that the 2D Unity system works is you have effectively a camera. Like I was saying, it starts as this -10 Z position in world space, but it's important to note that the Z coordinate of these objects do not matter. Now, there's a little bit of, importance here, right? Like if you push objects and you mess with a Z, you put it behind the camera, it's not going to see it. And so you do have to consider clip space and that kind of thing. But the orthographic view eliminates the sense of depth, although you can use Z to control ordering. So if I want to put an object behind another object, even though it's in 2D, you would do that with a Z. If you've ever used Photoshop or done any kind of web design, you're probably already comfortable with the Z depth value, which doesn't change the depth perspective of an object, but it does change the ordering in which it's presented to the user. So the coordinates in 2D are a little bit different in that instead of having this x, y, where it's 0 in the middle and then left and right negative and so on, it's actually the lower left corner is 0, and then you go up in positive x and you go up in positive y. So this is a little bit different. Sorry, let me be clear. This is the screen space coordinates, not the object coordinates. And so you do need to kind of know that there is this transfer between screen space and object space. So when you put up an object in a particular location in 3D or in 2D, the renderer is going to convert that first to what's called clip space, which is a range of -1 to 1 in both directions, and then that gets converted into the window coordinate system. And so this is kind of something you'll need to understand when you start to try to interact with the objects in the screen in 2D, which you may not be doing in the same way with 3D. So in short, right, you've got 3D game objects which are rendered in like a 2D view, but when you do it in 3D, those objects are technically still 3D in 2D, but in 2D you only get that projection. And so in 3D, let me see if we have our thing is open finally. Great. So just to kind of see what we've got here, same stuff, same as before. If we hit play, we don't see much. There's not really much to see. There's no objects there. We are in 2D mode. As you can see, we can switch from 2D to 3D. So if I put an object here, for example, let me put a cube. Great. Right, and as you notice, our 3D, our camera here, if you look at the camera settings, you'll notice that it's an orthographic camera, and it's positioned at -10, and so on. If I move my camera around, you'll see that square move around in what looks like 2D. If I move the square, if I move the cube, let's put this here so we can actually see what's going on. There we go. Here's our game. If I move the cube, it'll move, and notice I'm moving it in the X and Y plane, because if I move it in the Z, nothing will happen unless I go, well, even, yeah, within reason. You'll notice that the camera, let me go back into my 2D view. I want to have the same 2D view as the camera, however, but whatever. But you'll notice that the camera does have this sort of what's it called? It has a sort of bounding area. So like if you look in the top, let me change this to isometric. You'll notice that when this block moves past this line, it will stop being shown. And that's because I'm hitting that clipping what's called the box of the projection, because the projection does have like the start, like a near plane, and also a far plane. Similarly, if I move the box, well, I guess so. Yeah, if I move the box all the way up there, which I'm not going to do, it will disappear as well. So let me move this back here. But another thing you'll notice, right, is, oh my god, there we go. Another thing you'll notice is, let me move back to perspectives. This is we're more comfortable with this. If I move my my box here, great. But you'll notice that this block is still a 3D object, and I can rotate it as such. And it starts to do funny things, right? Like when I rotate it like this, you'll notice that it kind of is weird looking. It's kind of oblong. Doesn't really look like a cube. Another thing you'll notice is that there's no lighting, right? Let me add a directional light really quickly so we can see if you do that, right? It starts to look actually like a 3D object and change in response to the light source. So it just kind of goes to show that in 2D, it's really just a 3D, but with this perspective projection. And I want to note that you can move between the different, between 2D and 3D just by hitting the number 2 on your keyboard, which is pretty cool. Problem is, I'm not in line with the camera, so I want to sort of, I don't know why it did that, but There we go. Now I'm actually in the correct perspective. So you can sort of do this manipulation of stuff in 2D mode in Unity without having to be in 3D and trying to make that comparison. But you'll notice, like, what's the point of having all these things unless you want to make this 3D 2D game, whatever, if you only have 2D objects, right? So in 2D we have what's called a sprite. Great. What we can do is any 2D object could be a sprite, and a sprite is simply just imagine an object, but all the object consists of is like a quad or a picture with an image, like some kind of texture. And a sprite can be a variety of different shapes and things, and so this is actually, when you think about older games, I should say, like the first Nintendo with Mario, right, and all the systems that were in place to effectively render sprites. And one of the first times that sprites were able to do really complex things was actually John Carmack with this game called Keen Commander. He was able to do full screen scrolling with a sprite-based game. And so there was this whole era of games and development of games that were entirely focused on sprites. And still today, you'll find sprites everywhere, from full games made just on sprites, right? Like, for example, Mega Man, if you remember this game. And there are still full games that are very popular that are using simply sprites. But even in full immersive 3D games, you'll find sprites everywhere, from what's called billboards to create particle effects to creating grass. Sprites and the ability to represent 2D data in 3D is actually still very much a helpful thing. So in short, the sprite is effectively an image that's presented as a flat plane. As I mentioned back in the day, this was done actually at the buffer level of the video card, but today it's usually done in the context of a flat quad or a flat object of some kind, be it a triangle or what have you. So yeah, you can do everything with sprites that you can do with 3D objects. You can attach scripts to them. You can set up hierarchical relationships. Let's kind of play with this, and then we'll try and mess around with the tutorial that you would be doing with creating a clock face. That's up on my courses. So let me delete this cube, and let me create a new, you'll notice there's a 2D object here. There's a lot of different kinds of 2D objects. As you can see, there's isometric tile maps, and that's used for, if you've ever played a game that's sort of in an isometric perspective, like Command and Conquer or like Civilization kind of thing. But we're just going to play with normal sprites for now. And here's my sprite. Oops, I don't want to move. I want to move it. So great, my sprite has nothing. So to create the sprite, let's go. I'm going to bring in some content. Always good to have too many windows open. Right. One of these will be right. Great. Cool. So I'm going to go ahead and bring in these images. I'm going to create a little folder in my area here. And in here I'm going to bring in some images. You'll notice that I have these different sprites associated with it. Cool. So let me go back to my new sprite, and I'm going to rename this clock face. And I'm going to give it, I'm going to use this particular one. So let's find the sprite. Great, bam. Cool. Now check it out. Sick. Let me put this at 0, 0, 2 because I'm not going to be able to position it correctly. Not sure why that's not centered, unless my camera isn't centered either. So I guess I moved my camera earlier. Cool. Sick. Now I've got this terrific little clock face, which is nice. And next, I want to create a couple of. Let me create a new empty object actually, and I'm going to call this clock. And then I'm going to put my clock face into clock. Clock is going to be positioned at 0, 0, 1. And then all my other objects can be positioned at effectively 0. Great. And now I'm going to add a couple of arrows. Too big. And I'm going to call this one the hours. What is the clock? I don't know. I don't use clocks anymore. What is it called? Hour hand? Hour hand. Cool. I'm going to call this the minute hand. And then a couple of things we want to do. Let's see. It's way too big, obviously. So we're going to make this a lot smaller. Maybe 0.25. Is that too big? Maybe 0.1. 0.1. 0.1. That's a bit, I think, too small. Or is it? Yeah, it's too small. Let's make it 0.2, 0.2, 0.2. That seems about right. Let's do the same thing with this guy, the other one. The hour hand. Let's change that to... The hour hand should be a little bit bigger, right? So let's do it 0.3, 0.3, 0.3. It's a little bit too big, right? Because now, if I position it there, it's going to kind of be way too big. So actually, let's do this 0.22, 0.2, 0.2. And then I'm going to make this one more like 0.18, 0.8, 0.8. Still too big, maybe. Great, yeah. Cool. Now, there's an issue here in that it's not going to rotate about the right place. If I rotate this, which you can imagine, that's what I want to do. I want to rotate it about the center point. I don't want it to rotate around itself like that. I want it to rotate around a central position. So there's a couple of ways. One way is we already have the knowledge. We should be able to put this into another object, like into a composition where that will pivot about the correct place. So I think that's probably the smart way to do it, because otherwise we have to do all the math and to figure out where it is and rotate about a particular point, and I don't think that's necessarily something that anybody wants to do. So to do that, we're going to actually create an empty object that we can put into the clock, and I'm going to call this the hour hand. And I'm going to change this to the hour hand sprite. And just so we don't forget how to do this, minute hand sprite. In fact, I'm just going to delete this for now. And I'm going to put this into the there we go. Cool. And now, what you'll notice, the hour hand sprite is I'm going to position this around 0. And then I'm going to position this around 0 as well, but then I'm going to move it. So let's say first of all, I want to rotate it so that it's starting at the 0 position. It's going to be starting at the correct place. So I'm going to rotate it around Z by 90, apparently negative 90. Oops. Great. And now I'm going to up it by 0.22. Or not the prefab, yeah, great. and I'm going to up it by 1. 0.04 or 5. Still a little bit too big, isn't it? 0.2, 0.2, 0.2. Yeah. Great. I'm actually going to not do it at 1. I'm going to put the little arrow quill thing. So I'm going to put this at 9 or even 8 or 7, 5. Great. And now you'll notice if I rotate this, it's going to rotate the way I wanted it to, which is cool. Cool. I guess there's another way to do this, where we can actually do this in a more direct way. I'm going to create a new sprite, and I'm going to give the sprite the arrow, like we had before. And then I'm going to go and actually use what's called the sprite editor. And let's see how we get to that point. We can actually go down here, and when you click on the texture down here, we can actually click Sprite Editor, and this will bring up a lot of great tools, and I can actually move that position, or I can move it manually. Or I can do it manually. So for example, a custom pivot, I can move this to here. Bam. I can even change the sizing of the sprite, and then yeah, there you go. And now it's going to be better. You click, when you're done, you click this button up here that's very well hidden called Apply. Great. Now you'll notice that this sprite's all messed up now, which is not really what we wanted. It's going to be off. So we don't necessarily need to do that system anymore. And we can just pop one in. This is now a sprite. We can actually just pop a sprite in like that. If you want, you'll notice that it's around 0 now. And we can change the name to our hand, and we can reduce the size of it. You noticed it was like 0.18, 0.18, 0.18. Well, actually, that's a little bit small now. Great, so that's our, maybe a little bit bigger, even 0.22, 0.22, 0.22. And then let's make a minute hand similar. That's going to be 0.17, oops, 0.17, 0.17, 0.17. Great. And now we've got these two. It's almost looking like a clock at this point, which is pretty neat. So you can very easily position it as you'd like. Okay, so what's next? We also need a button, because we're going to use that in this way. There is no button text here like the tutorial says, so let's create let's create one with, let's just create one with paint. Okay, so I'm going to create a click to rotate clock hand. Oops. Too big. Always good to have, you know, a good font, even when everything else doesn't look that good, but whatever. Great. Let's see if we can just cut and paste it in here. We cannot. That sucks. Oh, no, we can't do that. It apparently keeps its own. Let's save this to wherever. No, let's. I'm not sure what's up with Windows and that, but cool. There. Cool. All right, great. Now I have this stupid thing here. So now we've got a button, and I'm going to change this to button or clock button. Cool. So now, for the most part, we've got a game that would be just a clock with another sprite that doesn't do anything. So if I hit play, you'll notice that it doesn't do anything, just like we expect it to do nothing. But already we do have a clock that, in theory, you can imagine would work. Okay. Not sure why Siri just went on, but fun. All right. So now let's do a little bit of interactivity. Let's actually change this so that it can work. So actually, let's get rid of one of these arrows for now. We're just going to operate on one. And we're going to add a new script. We're going to call this script rotate hand. Great. There it is. And let's go and open it up. We're not going to have too much in here yet, and let's create a function immediately that we're going to call void rotate to mouse. Great. And so, oops. Hold on, I'm looking for, great. Okay, let me zoom in a bit because I've gotten that feedback, which needs to be a little bit better. So first we need to get the position of the mouse. And to do that, we're going to create a vector3 mouse world position. And the way we're going to do this is we're going to get from the camera main, so that's like the main camera, and then screen to world point. And you'll notice there's a bunch of other functions that are showing up. We're going to get input mouse position. And that's actually a really eloquent way to get this, because often it's very difficult to convert, like, oh, you get the mouse position and you have to figure out what your window size is and you have to kind of apply it to your projection matrix. So Unity does a lot of heavy lifting behind the scenes for you in this particular call. And so, let's let's move on. And so now we want to figure out what the angle between the origin, or the xy origin, to the mouse is. And so to get that, we're going to set up a function called angle, and we're going to use the mathf library, and we're going to use atan2 mass world position dot y and mouse world position dot x times math. Well, let's talk about this bit right here. So like what this is doing is it's getting the arctan, or the arctan of the y and x position of the mouse, which will give you the radius. And we're going to talk about this in the review of trigonometry in a minute. But ultimately, right, the arctan, that there is the ratio between the x and the y, and that's going to be proportional, and going to give you the angle of that based on where you are. And what's nice about arctan2, this particular function, is that it accommodates the issues that you might have where y or x may be 0, right? So like in the case of 0 degrees, y is going to be 0. In the case of 90 degrees, x is going to be 0. And so it accommodates all of those sort of division by 0 errors, and makes sure that you get a correct radian value from this function. And then it's in radians, and we want actual degrees, and so we have to multiply this by the rad2 degree plus 180. Right. And the reason we're adding 180 here is we're shifting it to get to the orientation basis that we want, because everything is rotated already by 180 degrees, as we'll see. In fact, I'll take this off just so we can see what I mean by that. And then great, we can debug log that angle just to see it in action. And then finally, we're going to actually transform ourselves, or set our rotation to be equal to, what is this quaternion thing? We'll talk about that in a minute. 0, 0, angle. In short, the quaternion this is will set our rotation quaternion, and a quaternion is effectively a way to encapsulate orientation or rotation. Now, this won't do anything on its own. We do need to actually apply this to something. And so if is turning, which is something we haven't defined yet, so let's do that. We need to create this public bool is turning, and we're going to set that to true initially so that we don't have to turn this on in the editor quite yet. If is turning, then rotate to mouse. And that's it, really. And what will happen here, allegedly, notice, oh, well, what happened? Okay, so here's the issue I was kind of talking about. You'll notice it's rotating, and we're getting, so let me kind of point out to you again, right? At this point, the value here, you can see it in the debug log, maybe you can't quite see it very big. Right now we're at 0.19 degrees. As we move up, we're getting up to 90 degrees, 180 degrees, now negative 90 and negative 30. And so what you noticed is that we're going from 0 to 180, and then back to 0, and then we go to negative, and so we're going from like this 180 to negative 180. So if you add 180 to that, you've shifted that range up into the positive spectrum, and that's what we do with this line. So now, if I hit play, now the mouse, this arrow is going to try to point to my mouse. Oh yeah. Cool. Very fun. So that's great. And now let's talk a little bit about this Euler angle. The Euler angle thing. So again, a quaternion is, imagine a almost like a vector in space, and it's like a complex number, but in three dimensions. It was actually Hamilton that discovered this, and he was interested in complex algebra for, if you're familiar with complex numbers, right, like a plus ib, how would you do this for a third dimension? And so he was looking to do this with multiple dimensions of complex numbers, and out of this came a particularly eloquent equation, one that I can't remember obviously right now, but a set of algebra that really described 3D complex numbers in a way that has been proven to be able to be used to represent orientation in a way that's significantly better than just the Euler angles. Euler angles in particular are have the vulnerability of what's called gimbal lock. So when you take a value and when you take an orientation, you rotate it up to a certain point, you can't rotate it up anymore. The numbers transform in such a way that you no longer have a way to represent sort of local rotations without hitting this kind of limit at a certain point. And so what's nice about quaternions is that they're in a way absolute off of a relative point. So quaternions in and of themselves are not absolute, like no coordinate system, but they do not have to deal with this sort of gimbal lock. You don't get stuck in a particular point. You can kind of always apply quaternion to another quaternion regardless of where you may be and what those two mean. Quaternions are a pretty sticky subject. The math gets a little bit funky, and so the short of it is, imagine a quaternion as an orientation in space where the vector is effectively your orientation, and then the magnitude of that is a rotation about that vector. It gets a little wacky, but the short of it is, think about it as an orientation. And the way that you can use it in Unity is you can use a quaternion, and you can create a quaternion off of a set of Euler angles. And I want to say that this is actually really specific to the engine. So the Unity engine versus a different engine may give you a different quaternion based on a different set of Euler angles you give it. And that's because, like I said, quaternions are, there's a convention upon which quaternions start off at a particular orientation, and then another quaternion is applied to that quaternion to get you to where you want to go. It's kind of like unit vectors, and unit vectors technically, even though to us, XYZ, that's so obvious, but to somebody else it might be YZX, right? There is a set of convention. So just keep that in mind. And so this function, all it's doing is creating a quaternion off of an XYZ set of angles, and then you are setting your rotation transformation to that quaternion, which Unity is smart enough to understand to be, okay, set my orientation, set my rotation matrix to this this transformation, which is funny because underneath the math, it usually turns back into a Euler transformation, anyways. But whatever. So okay, now let's do something else. So first, I don't love this background color, so let's kind of change that. Let's go into the camera and we can change the color to white. well, let's make it gray. Great. And now we're going to also do a little bit with this button. We're going to now have this button communicate with the clock hand. And so first thing we do is we're going to create a new script here. And what are we going to call it? Let's call it button script. Cool. Let's open up that button script. And let's create a on mouse down, because that's exactly what we're doing, right? We're not doing much else. And so, cool, let's do this. What we can do is we can do a get component always fun to deal with get component. Actually, let's do this. We want to get an external script. So public in object arrow hand, right? And then on start, actually we want to do this as well. What's our name of our other stuff? Rotate hand. So you'll notice that the other script is an object, right? It's a class. So now we can do rotate hand script. And on start, we want to get a handle to that. And so the rotate hand script is going to be equal to arrow hand get component rotate hand. Great. And now we do need to. This will be private. We do need to actually assign the arrow hand there to this. Great. And now we can basically turn this that one flag on and off. So what we can do is rh script dot is turning is equal to not rh script is turn. Cool. That should be sufficient, at least. So now it's working. No. No. Why you no click? Well, does this button have a collider? Does not look like it. So we need a collider, don't we? Great. Let's make sure. Cool, the collider looks correct. Now let's do it. Great. Now it's not working anymore, as you'll notice. And now it is. Sweet. What else can we do here? Oh, I see. All right. So this is a bit of a thing we can do. Instead of using this previously created clock face, what we can do instead is use this blank one. Let's do that. Cool. Now we don't have any numbers, which is a bummer. So what we're going to do is we're actually going to programmatically create the numbers. So I don't know. I think this one. I'm not a big fan of this one, but all right, let's do it anyway. So we're in our clock. Well, let's create a new 3D text object. And so that's going to be right here, 3D text. It's very blurry. It's positioned at 0, 0, 0. Great. So let's scale it to, it's way too big. So let's scale it to 0.1, 0.1, 0.1. A little bit too small. I don't have to scale to Z. Whatever. And oh, great. 0.1, 0.1. And then we're also going to change the text size. There's the font size. Font size. What's the style? The font size, we're going to set it to 50. Great. Now it looks a little bit better. Great. And we're also going to change the the anchor to middle center. That looks better. And we're going to change its text to 1 for the time being. Let's move it over here so we can actually see it. We're going to add this now to the existing sprite. So we're going to call these the numbers. We're going to move this into here. Oops, there. And we're going to put this at 0, 0, 0 as well. And we're going to scale it to 1, 1, 1 for now. Great. Now we're going to oh, no. Actually, what we're going to do, clock number, we're going to put this in the global space. We're going to actually create a empty object that we're then going to parent it with. We're going to make a prefab out of this bad boy, and we're going to make this 0.1, 0.1. And this we're going to put at 0, 0, 1, 0. And then the prefab is there. Now let's create a new little folder down here. Prefabs. And I'm going to drag this into my prefabs folder. Cool. Now we have a prefab of this guy, but we don't need it here. We can remove it because we're going to be using everything through code. So now we have to create a object, like a script that runs at the highest level of this project. And so we're going to create what's called like a game manager. Let's just call it manager actually. And this doesn't have a position, but you know, for shits and giggles, you can put it wherever you want. And then we're going to create a new script on this guy. So this is actually a pretty common pattern within Unity. You'll have, you know, a script that all it does is it runs at the top level of the scene, of the game, of whatever. You know, so cool. Now we're going to use math to position all of the values, all of these numbers. And I guess this is actually where I'm going to chill out because this is really up to you. But I'll do one to kind of get you an idea of how to do this a little bit. So here is the object that we've created, the clock numbers generator. And the first thing we're going to do is we're going to, let me just show you guys how to get an object kind of created. So first we're going to do is we're going to create a game object, go, game object, instantiate, clock num, great. Why is it like that? Why? What does instantiate expect? Oh, I see. Fine. Okay, so I'm not going to position these yet. Cool. And now the thing is, let's see. Now the issue is going to be that it's going to require an object of some kind, and I think that I can just take this and stick it in there. So now I can create a prefab like that. And let me not put it, let's call it vector 3 vpos equals new vector 3. Let's put it at, 0.110. Cool. And hopefully, with a bit of luck, this should place a number for me somewhere. Cool, there's my number. Now you can imagine if I wanted to do this for I equals 5 or something. I'm going to get a bunch of 1s. Yep, great. And then finally, the last piece of the function that you might want to need is get component in children text mesh. That's going to be a weird one. And that's going to give you the actual text value. And then you can set it to sup no plus I to string. Great. And what this is going to do, hopefully, is we'll change the string of that mesh. Right. So to kind of go through this just a little bit again, we've talked about this in a previous lecture, but this syntax is a bit finicky. So this is just creating a vector of a position that's incrementing with I, and then this game object is being created through the instantiate of this prefab that's being set in the editor with a particular position, which is provided up here, and then with a quaternion identity. So you can imagine if I wanted to, for example, rotate this a little bit. We were talking about this before. I want to rotate it about z, so 0, 0. Say I wanted the numbers to line up with the clock face itself. I could actually multiply this by, let's say, I want to do 360 divided by 5, because that's the thing that we're doing. Make sure you close the brackets, and you'll notice that when I do this, hopefully it will also rotate it. Cool. So you can see how kind of versatile a lot of these calls are, and then hopefully this makes a little bit of sense, and this should be sufficient for you to really kind of create these clock face numbers on your own per the assignment. So I'm not going to do the whole thing. I want you guys to be able to do it on your own. But using trigonometry and understanding how to position things and the clock face size and that kind of thing, you should be able to kind of get to a point where you can create something, right, that looks like this. Cool. All right. Thanks for putting up with me kind of bumbling through that one. But yeah, as you can kind of see, 2D or 3D, Unity is a pretty kind of full depth engine. Like you can kind of do whatever you want with it. So yeah, with that, I'm going to switch over to our next lecture on trigonometry, which will obviously help you a lot with this particular exercise. So recommend you watching that before you really attempt this on your own. Okay.